Hello, I'll be going through problem 20 from the practice exams for exam 3. The first example was this 2x squared minus 12x plus 3, and the instructions said to rewrite by completing the square. Observe that the leading coefficient is not 1, so this is important. We'll need to factor out the 2 out of the first two terms. The 3 on the far right is just going to hang off to the right. Okay, the action is going to happen right here. Just to check, make sure I'm right. 2 times x squared is 2x squared. 2 times negative x is negative 12. Okay, all good. Now, in the parentheses, we're back to the old routine of looking at the coefficient of x, which is negative 6, and starting with that. So in blue, I write negative 6 times 1/2 gives us negative 3, and negative 3 squared is 9. So in the immediate sense, at least, 9 is the magic number, which I'll write there. Now here's the problem. I have brought 9 right there, but in the bigger context, what I brought into the entire situation is not just 9. It is 9 times 2. Because of distribution, we have to be mindful of this number off to the far left. Therefore, the number I brought in really out of thin air that I need to compensate for is 9 times 2, 18. So therefore, I have to subtract out 18 on the far right. Okay. Next is the idea that if we've done our job right, we have a perfect square trinomial in the parentheses. And let's write out a squared binomial and see if that works. Let me just take care of this. 3 minus 18, I believe that's minus 15. Okay, now let's check the squared binomial. Let's make sure that is correct. X squared, yeah. Negative 3 squared is positive 9. Yeah, good. Now for the middle term. 3 times x, 6x, minus 6x. Well, I'm sorry. I'm jumping the gun there. 3 times x is just 3x, minus 3x, and now we double that, and that gives us negative 6x. So we're all good. And, yeah, that's it. I mean, there's nothing more to do. So I'll just put a box around that. Great. Let's go to the next example. This should be from B. I believe I'm doing this in the correct order. Okay. All right, so here we go. 3x squared minus 12x plus 9. Same instructions. Use completing the square to rewrite. And we do have the issue of the coefficient, the leading coefficient not being 1. It's 3. Therefore, we have to factor out the 3 out of the first two terms, just the first two. It does not help to try to factor 3 out of all 3 terms. It totally messes everything up. It just works out that way. All right, so here I've done that, I believe. 3 times 4 is 12, and then negatives, that checks. 3 times x squared, great. Leave a little space here because now we need to compute the magic number part. Let me try using green here. All right, let's try this. Okay, so we're now going to try to compute the magic number. So we look at negative 4, multiply it by 1/2, which is the same thing as negative 4 divided by 2, but I find it sometimes clear to express all this by multiplying by 1/2, but let that go. Minus 2, though, is the result in either case. Yeah. Negative 2 squared, though, is positive 4. So 4 is a number that needs to come in, the magic number, so I'll put that right there. Yeah, now careful, because what we have brought in terms of the big picture is not just 4. It's not just 4. It's 4 times 3, which is 12. So we need to compensate off to the far right here. We need to keep the balance secure. If we've done our job correctly, the next line would be the binomial, the squared binomial stage. Well, how do you compute the numbers that need to go in there? It's a very quick thing, really. The square root of the first term of the binomial, that'd be x. The square root would give you x. The square root of 4 is 2. And the only other issue to fill this out is what is the operation inside that binomial. It'll be the same as that operator, so therefore subtraction. We'll come back and check that in one moment. Here on the far right we have 9 minus 12. I believe that gives us minus 3. And now to check the binomial. Did we really do right on that? Well, let's see. Square the first. X squared gives you x squared. Right on. Negative 2 squared is positive 4. Yes. X times 2 is 2x. Negative 2x, the multiplication, but double that, negative 4. It checks. We're good. Put a box around it. We are done with that. Okay. Great. I believe that came from B. Next would be the problem from, I believe this is from exam C. Practice exam C. Okay. All right. Okay. Good. Yeah. Right. So here we go. Getting to be kind of repetitious, right? We don't have the leading coefficient's not 1. We got to compensate for that or adjust things to make it all work. Now let's see. Now make sure this works out. 3 times x squared, 3x squared. Yes. 3 times negative 2, negative 6. So the distribution checks very nicely. Now to get the magic number aspect, we'll focus on the negative 2 part. Negative 2 times 1/2 is negative 1. Square the result. Negative 1 squared is 1. So we bring in 1 right there, but always be careful. In reality, in the big context here, we have not brought in just 1. We brought in 3 times 1. Therefore, we have to subtract out the 3. And finally, I believe, if we've done our job right, negative 9 minus 3, negative 12. Okay, the binomial should end up being this, but we'll check. I always do. I really do. Let's see. Square of the first, x squared. There you go. So 1 or negative 1 squared is positive 1, yes. And then x times 1 is, or x times negative 1 is negative x. Double that will give you negative 2x. So we're good. We're done with that problem. And just one more. Now, so I believe this last one is from practice exam D. This is a B, not 6. Sorry, that's a little unclear here. Let me try to write that a little better. X squared plus BX. All right. Now the idea here was, okay, can we see the pattern? Observe that the leading coefficient is 1, so we don't have to worry about this idea of factoring out. We're just gonna. This is more like problem 19, and I think in the practice exam D, that was the idea. I had the 19 kind of look like problem 20. It just had a 5 instead of a B. I think that's what I did. Anyway, so what we do is we take half of B. We're now finding the magic number. So you take half of B times a half, which can be written as B over 2, and then you square that number. You square that number. And I think it would be helpful to actually apply the exponent to the top and the bottom. You'll have B squared over 4. That's the magic number, B squared over 4. So just proceed just like we have. So we have x squared plus bx, and then plus the magic number, which is b squared over 4. Put some parentheses around it, and then remember to subtract back out the magic number. To keep the balance right, we'd have negative or minus b squared over 4. All right. The theory here is that this expression, this trinomial, this 3-termed expression inside the parentheses is a perfect square trinomial. And that will be true, really, if and only if what I'm writing out here is going to work. All right, well, let's find out. Let's check the squared binomial if it actually works. Well, the square of the first, x squared, is the first term of the trinomial. Great. The last term, okay, we're going to square b over 2. If you square b over 2, you get b squared on the top, which we do. 2 squared is 4, so that part checks. The last step is to see, is the middle term correspond right? Well, what you do is you multiply your two terms. So you'll have x times b over 2, and just double that. If you're doubling a half, you just get back the numerator. Let me just write that out because that's probably asking. So here we are off to the down here. It's multiplying b squared over b over 2 times x, and then doubling it, doubling the product. 2's cancel out and are left with bx. And the question would be, is bx the middle term of the trinomial? Yes, it is. Therefore, everything is good, and we can just put a box around this, and we are done. So see that the process does not change a single bit if we start using a, b's, and c's instead of, integers for our coefficients. Okay, I hope this is helpful. Please let me know. Thanks.